Well, we're very excited tonight for our presentation with Annalise Record to educate us about the progressions of division. If you don't know Annalise, you're going to get a lot of information. You're going to see a lot of passion from Annalise. Annalise loves what she does. We love what she does. She's one of our favorites. There's her contact information. She is a consultant who works with schools and educators all throughout the country. As a matter of fact, I think she even got finished working with somebody in the Netherlands or something. I don't know the whole story, but she is global. She is awesome. She is one of our favorites, and I am going to get out of her way so that she can do her thing, and I will figure out the code as we go. So, Annalise, it is all yours.
Great. Thank you so much, Mark. I'm thrilled to be with all of you tonight. So excited to join in again on a webinar talking about the progression of division. So I want to take us through the grades 3 to 5. I want to start off with the beginnings of what division is, the different story structures of that, as well as taking us into just talking a little bit about basic facts, into the multi-digit work, and even a little bit of grade 5 with the division with fractions of whole numbers divided by a unit fraction and unit fraction divided by a whole number. And so let me share my screen for you as our beginning my beginning slide here. And so this is our agenda for tonight. We have the early explorations of division, and I want to show you that connected journey. I was a grade 5 teacher in Northern New Hampshire for 13 years. Then I became math coach. When I became math coach K5, that's where I had to learn, number one, about the early numeracy, where I had no idea the sophistication needed for even younger than kinder. It's a whole world down there of early numeracy. But honestly, the more that I learned, the more I saw a connected journey between the grades. I did not really have an appreciation for that when I was in my 5th grade classroom. And so I want to share with you this progression of learning because all of our students are at different places on this journey. It's about finding out where the students are, what can they do, and then help link what they can do to what we want them to learn, right? That asset mindedness that every single student deserves to be met where they are and provide access to the core curriculum of the grade levels. So I want to talk about the basic single step and single digit numbers with division. I'll go into some multi-digit division as well as the fractions a little bit of the grade 5. That is my plan for the evening. In this very quick, it will seem 1 hour time together. I want to begin with this quote by Howden about number sense. And I'd love you to put in the chat bar any phrases that stand out to you. Anything that just resonates with you and it just kind of stands out in your mind, how we're building
Annalise,
numbers.
oh,
Yes.
Annalise, while folks are thinking, my apologies. The code is DIV 2024, not just 24. I put it in the chat. So thanks, folks. Appreciate your patience.
Perfect. Thanks, Mark. Yeah, so I'm seeing here the intuition. And when I read intuition as a teacher, I'm like, okay, well, how do I teach intuition? Right? Like, how do I actually teach that? Because for a long time, I thought I had knowledge in my brain that I had to put into the brains of my kids, as opposed to me being a facilitator of their learning and providing them rich opportunities to think mathematically and to know that progression and help facilitate that. And so the intuition is built over time, right? So that word of gradually it happens, but it's a result of exploring numbers, visualizing them in a variety of ways. I love the Brainingcamp site, all these variety of manipulatives, so you see it in a variety of ways. And then relate them in ways that are not limited by traditional algorithms, which is how I was taught when I was a kid. It's the only way I knew how to calculate answers in my early years of teaching. But I live by Dr. Maya Angelou's quote, we do the best we can till we know more. And when we know more, we'll do better. So thank you for all those phrases. And I can see the developing gradually, the visualization, so crucial for every single brain. It's not just for certain kids who have a visual brain, it's for all of us. And if I choose to enter a task concretely, I shouldn't be frowned upon or stigmatized because I chose to use concrete manipulatives. It's about connecting it to the pictorial representation and then the abstract and connecting the representations together all the time. If I could rule the world, I would have manipulatives within arm's reach of every student at all grade levels at all times, or at least a computer with Brainingcamp within reach of every student at all times, to allow them to think through however they want to begin and enter tasks. And so you will not see me tonight go on about the long division standard method of division, because that is actually a sixth grade standard. And so I'm going to be covering grade 3 to 5 tonight. And there is, long division is a part in our standards in the journey, but the goal is not to get every single student to do the algorithm. The goal is for students to know when to choose to use an algorithm and when they don't need to. That's the goal, building that flexibility of thought, that there is more than one way to help students divide numbers, right? And building their number sense over the course of that time. So I want to begin here first with this situation, 18 divided by 6. I'd love you to write me like cliff notes of a story problem. Like, what situation can you think of that 18 divided by 6 is something that I would do to then solve that problem? So I don't need all of the text in like 5 sentences, but can you give me a story situation that 18 divided by 6 would solve? Okay, I'm looking through. Oh, here's my first one that I saw. Okay. So I scrolled through a whole bunch in the chat bar, and then I got to, I think Jacqueline's how I would say your name, Schuler. 18 students, and there are 6 in a group. Before that one, all the ones that came previous to that were about fair sharing. I have 18 things, and I'm sharing it among 6 students. Or I have 18 kids. Oh, there it was. Sorry, Danielle, you had the 6 in each group. How many groups? Thank you. So this idea of having 18 objects and fair sharing them among 6 groups is one way that division can be involved. But we also want to think about the other meaning, which is the quotative measurement version of division, which is we know the size of the group. We don't know how many groups. Now, that also is both equal groups. And I'm scanning down to see if I see any arrays. Do I see anyone talking about there being rows in a garden, or shelves on a bookshelf, or rows in a parking lot? And anyone mentioning rows? There's so many of you, which I love. Oh my gosh, 100 new messages. I can't read them. So I'm wondering how many of you would have thought about there being arrays, equal size groups, 18 objects. They're in 6 rows. How many were in each row? Or maybe there were 6 in each row. How many rows, right? And then I'm also wondering if anyone thought of multiplicative comparison. So this is the world of the problem types that involve multiplication and division. This is the research of Thomas Carpenter and his colleagues and their book, Cognitively Guided Instruction, these problem types. And we'll be going over that tonight. That's really an important piece of this. As we explore operations, we want to explore them in context, because actually that context, their research showed, affects the thinking of the kids and how they're actually solving the problems depending on the context. So that's one piece of the story tonight. And the other piece of the story is the calculation of getting an answer. So I'd like you to think about 288 divided by 24. I'd like you to try to do that mentally. And I also want to think about how you would make your thinking visible. So what was your thinking to figure out the answer, and how could you make your thinking visible? 2 pieces of this part to it. All right, super. Thank you all for putting that in the chat there. So from myself, I only grew up learning algorithms. So I know that if you had asked me that about 10 years ago, before I began having any flexibility of calculating numbers and answers, I would have thought to myself the long division. I say 24 goes to 28 once. So I know my first digit was a 1. There is 4 left over, and that 4 joins the 8 as I would bring down the 8 to make a 48, right? And 24 goes into that 2 more times. So I knew I would have 12. I'd have the 1, but I was thinking of it as a 1, not as a 10, because I was doing that long division algorithm, right? And then I'm curious, how would you make that thinking visible? So I'm seeing many of you putting the the numbers that you're working into it, right? But how would we make it visible for students? How would we make this kind of thinking visible to the kids? I'm curious. I know I saw someone did an array. Yeah, love it. Using arrays, we can make that visible for the kids. Chunks on an open number line. Money, ratio table. There we go, base 10 blocks. These are your models, right? So strategies are, what do I do with the numbers? Some of you mentioned about scaling up and scaling down. So I'm having strategies based on the number sense that I'm working with the numbers. The other piece of that is our models, which is how we make that thinking visible. These are all your manipulatives, all your pictorial representations of those as well. So all that you're mentioning, the base 10 blocks, area model, number bonds, those are your models, how you make that thinking visible. I'll have teachers tell me that they've been working on a number line as a strategy. And I'll say, well, that's not a strategy. That's actually a model. What are you doing on the number line? Because I can show you on a number line skip counting, or I can show you a relationship of jumping 10 groups to come back a group for 9 groups, right? We can be showing the different thinking on that same model. All right, super. So I'm going to think about my favorite way of showing the thinking of multiplication and division is using an area model, because this will follow the students all the way through from whole numbers into the multi-digit work, into the decimals and fractions, and even polynomials in high school. It is a crazy powerful model. When I learned about this for the first time, uh, I was mind blown. I thought, my gosh, I can do something with the kids in 3rd grade that will help them in the algebra with polynomials. I mean, I'm all on it, right? So we think for a moment about this 288 divided by 24. What I relate it to is thinking about, well, I'm trying to see how many 24s can fit into 288, right? So I think about, do I have enough for 10 groups? And because that's relatively easier for our students, those multiples of 10s. And so 24 groups of 10 would be 240, right? And now how much more do I have to go? That's where I would do some subtraction, right? And I can use the addition to find the distance if I want to. That 240 up to 288 is 48 more, and that's 2 more of those 24s, right? So what is that horizontal distance? That 10 groups plus the 2 more groups, that makes the 12 groups, right? So 288 divided by 24 is, of course, the 12. But that powerful area model provides access for so many more students that I know I provided it for in my 5th grade classroom, where I did not know better yet. Now I know better. I would definitely do things differently if I had my a classroom again. So what I want to share with you tonight is a whole progression of from 3rd grade, beginning exploring of division. How can we help the kids get to that point and build that, even some mental math that students may never have thought they could do before? How can we get the kids there and then even go beyond into the fraction world as well? And I have what are called share codes. So if you have not joined into Brainingcamp before, Brainingcamp offers the feature, which is phenomenal, that you can put anything on the screen in one of the apps and you can grab a share code. And if you give that code to your students, then your students are brought into that app with that already on the screen, and then they begin to do and work on that task. It's individualized. No student can affect the work of somebody else. It's not like you would have given a worksheet and photocopied it and given one to each kid. But so that code, they also don't expire. So as you remember at Brainingcamp, that you can hang on to those codes and use them as you see fit. So I have that I'm facilitating with tonight to facilitate my journey with you. And Mark will be getting that to you in some form, a PDF of all these codes. So you'll have these codes moving forward. So I want to begin talking about what most of you thought of tonight, which is equal group story problem types. We've got equal groups. And many of you, I would say most of you, also thought of this fair share thinking of what division is. It's the fair share. Let's think about what that does to the thinking of the kids. So here's an example of Nell having 12 apples, and she wanted to put them equally into 4 baskets. How many apples can she put in each basket? Of course, crucial, we have the word equally sharing, right? Now, when the kids are solving problems like this is the Thomas Carpenter CGI for short, cognitively guided instruction, where I grab the 4 that I'm dividing by, and I have 4 baskets, And that 4 that I grabbed, I'm going to separate each one of those and give 1 to each basket. And then I can grab another 4 and I'm going to put 1 more in each. I'm fair sharing it. So I'm grabbing the amount of the divisor and then I'm equally fair sharing it among the number of groups that I need, that I know that I have, right? And so at this point, the answer is, well, what was that fair share? What was fair? So I can look at one of these groups. So for example, this basket 1 has 3. So I have my 12, I divide it by 4, the answer is 3, right? So that's one way, and I think it's the most frequent way. So I'm working with schools and districts across the country, and I'm self-employed as a consultant. And so I ask people to write me story problems, both for adding and subtracting and for multiplying and dividing. And these are the most popular that happen 95% of the time. Of this in the world of multiplication and division, when it's division, it's always that fair share where I know the number of groups. So I want to make sure we're exploring tonight and building all of our math minds on there's more to the story to division. What other things? And because if we don't own them, then we can't think of them. And I know I didn't own them years ago, but now that I do, I think of other possibilities. We want to make sure we're exposing our kids to all these different ways to be thinking through what division means. So I'm still sticking in equal groups right now. I'm in the Linking Cubes app. So this is part of our 3rd grade year, right? So Nell has 12 apples, but she wanted to put them in baskets that fit 4 apples. How many baskets can she fill? Now, I couldn't draw for you the 4 baskets yet because I don't know how many baskets. What I do know is there is 4 to 1 basket. So students will take from the collection the amount of the divisor, and then they'll put it as one group. And then they grab another 4. I'm just going to copy here. It's a nice feature within the Brainingcamp. You can copy the images. I'm going to grab the 4, what I'm dividing by that 4, and make a second group. And now I'm going to just move those into a nice collection, make a copy of this. And I could put those 4 into this separate. So I know I had a basket 1. I might, just to save a little time, put B2 for basket 2 and B3 for basket 3. I do have students label the modeling of the story, the structure of the story problem type. And I have them put the word for context at the top here, basket 1. So I know that it was that basket. So hopefully our students will be able to tell the story of the story problem just based on the model that we draw. That's a really powerful way to provide access for every single student to visualize the story problem. So of course, in this case, the question was, how many baskets can I do? Well, now here's where the answer exists. In this context of a quotative division problem, quotative being the measurement model where I know the size of the group, well, it was 3. So there's where the 3 exists in this model for the equal groups. Now, I don't want to forget about the other problem types. So I want to show you all the problem types tonight, while I also talk about the mathematics of the solving of the problems as we get a little more sophisticated here. So here we're in the Rec and Rec app. I love Rec and Recs as well. And you can see that I have the, I already did the answer. I was acting it out earlier and changed the code to change something else and pretend that wasn't there. Okay, so for an array story problem, a parking lot has 24 cars parked in 4 equal rows. How many cars are in each row? This is kind of that fair share, right? So I know that this is 4 rows. If I have 24 in all, how many more can fit if I have the same in each of these codes? So this is, again, that fair share where the kids are going to say, well, I can take 4 and then I can give 1 to each row. So each one has 1. We can help our students be a little bit more efficient by asking them, are there any larger groups we can do right away? Like, do I have enough to give each of those rows 2 cars? And how much would that be? Well, 2 cars in each of the 4 rows would be 8. So I can maybe move those over together. Right. And we also can be keeping track on the side, having like 24 minus the 4 minus the 8, having that repeated subtraction of taking away the groups that we're doing. I might have enough for now 2 more groups of 8, which is a 4, making the 8. And then I would have 4 left. So I have enough to do 1 more in each of those groups. And of course, then we have that, what is the fair share? What was in each of those rows? And it would be that 6 groups, right? So again, that thinking of the fair share where I'm giving 1 to each group can be advanced into, can I give 5 to each group. So what if we did that, right? So I'm back to having my rec and rec reset, and I'm going to say to myself, well, there's 24 cars and 4 rows. Do I have enough to give every row 5? And a lot of our students do know that 5 times 4 is 20. So there we go. This is that multiplicative reasoning, where I'm using larger groups of groups to help me get to my total. So at this point, now I know 20 of those cars are in 4 equal groups because there are 5 in each group. And then, of course, I can do just that one more 4 that gets me to the total of the 24. So that, again, the fair share being that 6. I do want to show you over here on the right, the pictorial way of drawing the structure of the start problem type as well, because this has been shown with the research to be so powerful for all of our students to not only, we first can make the visual with the manipulatives, but then it allows us to visualize, right? So we connect the concrete to the pictorial. And now when I read these story problems, I am visualizing these models. It helped build my confidence that I know more strongly that what I'm doing is the appropriate thing. So making these models a really important piece for problem solving. So in this case, we have the 4 rows. What I don't know is how many in each row. And you can put that 24, maybe something like this, a symbol like that, to show that all of those all together are 24. But however you want to do it, if you want to do a bar model as well, right? So I'm using these bar models here. But whatever kind of symbol you want to show that all of that adds up to 24 is really powerful. And then, of course, we want to connect that to the abstract. So I've hidden part of my screens kind of facilitate tonight together. So, of course, this parking lot having 24 cars and 4 equal rows, it can be represented as 24 divided by 4, right? So certainly that's one way that we can write it. But could I also write this? 24 equals 4 times something. Now, I'm doing 2 things here for you. Number one, I am showing that we can represent division as the related multiplication, right? This is the research really heavily on fact fluency. In fact, our new book, Dr. Nikki and I and Dr. Allison Mello have written our second book in our fluency on multiplication and division. It is coming out this spring. It's actually in the hands. We have our cover now. And so this is the world of our book that we've written for all of you. The fluency doesn't just happen with multiplication and division. And so the idea with division, when you look at the research of how do we help kids think through division, it very heavily relies on big multiplication, right? So if I think about 24 divided by 4, that also means that 4 times something is 24. And maybe I know my math facts. Maybe I know 4 times 6, in which case I know now that missing number. What I also did for you, though, is I put the 24 on the left-hand side. We need to make sure that our students are seeing equations with the answers and the symbols for the unknown on the other side of the equal sign. The equal sign is a relationship symbol, right? The value on the left is the same as the value on the right. It's a relationship. It is not action. What our kids do is they think that when they see the equal sign, they must do whatever calculations on the left-hand side without attending to the balance. So we've got to make sure we always put answers on the left-hand side as well. Give them the opportunity and the exposure, because right now it'll look tricky to them. They'll tell you, nope, that can't be true, because they haven't seen it on the left-hand side. So I'm going to infuse all these different mathematical things for you tonight to cover a lot in our 1 hour. So, all right, so that was arrays. And now I'm going to show you again an array, but now I'm going to know the number in each row will be known, but the number of rows will be unknown. This is that measurement that goes along with the quotative division, where I have I know the size of the group. Now I'm in the number line app. So we're going to be moving into now the skip counting world, right? So we can be moving objects one by one, giving a fair share. We can count out 4, make a group, and the kids could be counting in that world, right? So counting still exists even with the work of multiplication and division, for sure. I have seen 5th graders count one by one in each equal group. So it still exists. We need to be aware of that thinking so we can help facilitate that moving forward. So in the world of that repeated addition, right, and being able to have the skip counting come into place, here's another array story. A bookcase had 6 books in each shelf. How many shelves were there if there were 18 books in all? So here's an example of a tape diagram model here. So shelf 1 has 6 books. I had to do a ... because I do not know how many shelves it's going to be. Now this also will help because the same structure exists for larger numbers, multi-digit numbers. I'm not going to draw 1,144 rows for something, right? So certainly we can do a ... and then this is the last one. So shelf something. I don't know. That's where the question mark is for the unknown. What I do know is that there are 18 in all. So again, I can be thinking, well, I know the size of the group. So how many sixes will fit into the 18? And so I can show that on a number line, and I can be doing my jumps. So I can show I have my first six, that's one row, and then I can copy it again, that's two rows. And then I can fit another one in there. And there's that three shelves. So I have three shelves, each having the six books, right? So I'm moving into that repeated edition. Now, sometimes kids may not have learned their higher math facts yet. And so I witness them very often when I ask them on a math writing record, which is a fact fluency assessment by Dr. Nikki Newton. I ask them 6 times 8 in the multiplication. And at that one, they'll say, oh, well, I know that 5 eighths is 40, 41, 42, 43, 44, 45, up to 48. So they combine the counting and that additive reasoning sometimes when they're doing their work as well. And our goal in grades 3 to 5, remember, focusing tonight on grades 3 to 5. This is a grade 3 to 5. The world of multiplicative reasoning starts in grade 3. That 3 is a tough year. We're coming in from the adding and subtracting world and moving them into the multiplication and division world and introducing fractions. So 3 is a big year right there for sure. And so again, we have here an array, and I'm choosing to solve it on a model of a number line, and I'm using skip counting as my strategy. I want to think about the repeated addition. So there we have the equal groups and the arrays. And then I want to show you this one. This is such a crucial problem type. It is typically reserved for grade 4, although you may see it in grade 3 to kind of introduce it to the kids. But the research of Thomas Carpenter and that cognitively guided instruction does show this is a harder problem type. So it typically shows up in grade 4. So Jen read 24 books and Denise read 6 books. How many times more books did Jen read than Denise? Now you notice I'm in Cuisenaire rods. They are my favorite manipulative. They are the key, I think, to help move our students from counting into additive reasoning and additive into multiplicative reasoning, and then into proportional as well in the grades 6 to 8 world. And they exist as a group, right? So in our additive reasoning, we're trying to find groups within numbers that we can add and subtract. In multiplication and division, we're trying to find groups of groups. That's that multiplicative reasoning. So if I model the structure concretely first, I know Denise has 6. I know that Jen has 24. Now, Jen has this pink bar. This is the benefit of doing the virtual Cuisenaire rods, is you can have one rod that's flexible with the size, right? That doesn't exist in the concrete world. But this is the relationship, is that there are two groups. There's a Jen having the 24. And so just for tonight, I'm going to label that J as Jen and this D for Denise. But I would spell out those words, have the kids label them with words appropriate to the story context. But so here's Jen having read 24 and Denise read 6. How many times more? So the relationship is a multiplicative relationship. And in fact, it's that same repeated 6s. It's the amount that Denise read over and over and over again to make up the total amount for Jen. So it's a multiplicative relationship. You can see it's 4 of those 6s, 4 times as many. And so when I show you first here, I built this concretely. What we can do is we can also then have the students draw it, right? Concrete, pictorial to the abstract, and connecting those representations whenever possible. So take a look how the tape diagram model matches the Cuisenaire rods. This is one, I just love Cuisenaire rods for so many reasons. But this is one of my favorite reasons, right? It's the exact concrete of the tape diagram models, which we can begin to help the students visualize the structures. But what's going to happen is the numbers become larger. They become decimals. They become fractions, right? They become bigger, but the structure is remaining the same. We're providing access for all of our learners, right? So powerful. So being able to draw the amount that Denise has, that Jen has a total of 24, and we don't know how many 6s it is. That's our job to figure it out. And then again, I want to think about the thinking of the kids. So how might students figure out how many 6s are in 24? I have witnessed kids go 1, 2, 3, 4, 5, 6. That's one group. 7, 8, 9, 10, 11, 12. That's a second group, right? Counting all the way up, and they realize that it's 4 times, but they're counting everything. They're counting all the amounts in each of the equal groups. So I know as the educator, I want to help move them into that repeated addition of the groups, and then get them into the multiplicative reasoning. Are there any amounts of sixes you know for sure? Because if you know 3 6 is 18, you don't have to go 6, 12, 18. I know it's 18, right? So we're moving them into that multiplicative reasoning. That is certainly our goal in the grades 3 to 5 over the course of those 3 years. Again, providing opportunities that gradually over time allow our students to see things in a variety of ways. So I'm going to bring you into the base 10 group now as we move into the multi-digit work. Let's think again about that fair share story problem that you have. There are 66 books donated to a second grade. If the books are shared equally between 3 classrooms, how many books can each classroom have? Well, now you get larger numbers, but I still have that fair share. 3 classes getting the same amount. Here's my total. Well, now I could say, well, I have enough to give 10 to every group. That takes 30. So over on the side, I could be having my 66, and I just removed 30 to give 10 to each of those 3 groups. So I still have 36. Well, I have enough to give 10 more to each group. So there, I take that another 30 and give 10 more to each group, which means I want to now make sure I record that I've just now taken away 30 and distribute it to the 3 groups. I have 6 left. And of course, at this point, hopefully the kids might say, oh, I can give 2 to each of the groups, right? So I have nothing left. And of course, the answer is, what is the fair share? Well, one class, each of them got 22. So the fair share of one group is that 22. So certainly, as we go into the larger numbers, kids are still doing that thinking of fair sharing. And they need the experience to be able to do that, be modeling this thinking, right? Now let's move into, I want to show you the area model for this, because this is what has transformed my own thinking of division. I did not have this thinking about 10 years ago. But the more that I've done this now, I visualize it now. I can't tell you how many more mental math things I can do now because I'm visualizing that area model. So just imagine for a second, no matter what the context is, whether it's multiplicative comparison or arrays or area, if I have a factor that is unknown, right? So it's involving division. Well, I could use multiplication thinking, right? Which is what we're going to go into actually. We have a factor that is unknown. Well, I want to build a rectangle. Now, remember, every multiplication problem will result in a rectangle. Every single one, even if it's polynomials with algebra in high school, it'll always result in a rectangle. When we are thinking about a factor unknown, we know the area inside, that's the dividend. The divisor is, we can think of it just conventionally as the vertical distance. This horizontal distance is going to end up being the quotient. So if I'm thinking about building a rectangle and I've got 66 to do, I have enough to build a 3 by 10 rectangle with this area, right? So I have already, I know the answer will be at least 10. In fact, I can even put this 10 rod over, I can rotate it and I can put it right above that. So at least 10. I've made an area model, rectangular area model that measures 3 by 10, and that takes an amount of 30, right? Now, I actually have enough to do that again. So I can move that up there again. I'm now doing another 10. So now I've got 10 and 10, which makes that 20. So I can even, whoops, didn't mean to do that. So I've got my 10 here and my 10 here. I've got another 30, just so you can visualize that, that 10. And then I have 6 more, right? So I can do 2 more, or sorry, 2 more groups of 3. And so I can be taking that same 66. This amount that I started with has not changed. I'm just reorienting it to make it into an area model, right? So I have this distance of 3 by, well, what is my horizontal distance? It's a total of 22. It's made up of 3 partial quotients, 30, 30, and 6, of 10 groups, and 2 more groups. Now, how did I do that pictorially? Well, I can think about that I have my rectangular area model. This area inside will be 66. I want it to add up to 66. And so I'm thinking about it. We can think multiplication to help us with the division. I can say to myself, do I have enough to make a 3 by 10 rectangle? And I do. That would take 30. Then I can say a little bit more efficient now. This progression leading the kids into a little bit more efficient. Can I do 20 groups of 3? Yeah, that would be 20 groups of 3 is 60. Now, I know it's 60, not because I did 2 times 3 and I added a 0, we need to make sure we're not letting our students say they added a zero, because they're not adding a zero. It's a shifting place value position. These digits are becoming 10 times bigger. And the more we in grade 3 and 4 talk about, well, grade 3, we talk about it as tens. I have 3 sets of 20. So I have 3 sets of 2 tens, which is 6 tens. But I also want to be thinking about the fact that in grade 4, we have every digit is 10 times the one to its right. So I can think about it as being 2 times 3 times 10. You're essentially breaking apart that 20 into 2 times 10. So please be sure to do that. So grade 5 teachers will thank you, because when the kids get to decimal multiplication, they're not just putting a zero at the end, because in decimals, the values don't change. It's a rule that expires. So in any case, so here we have our 3. I can make a 3 by 20 rectangle, and that's 60. Now I'm going to do a relative proportionality here. I'm not going to do a line just straight down the middle, because I'm mostly there, right? My 60 is mostly to the 66. So I know that a 20 by 3 makes a 60. And how much do I have left? Well, that's where I would be subtracting over to the side to see how much I'm dealing with left. I've got 6 more to go, which is 2 more 3s, an area of 6. And so this is my vertical distance, right? My 20 plus my 2 more groups. So it must be that 22. Now, I want to show you an example next here that is something that I ran into a lot in my 5th grade classroom, which was when we have zeros in a quotient. The students were just, because I did the long division method of division because I didn't know any other way. I wanted them to always understand why the algorithms worked. I know I did work like that, but I didn't have any other way to do it, right? And so this 4,004 and divided by this 4, let's think about that area model. Of course, I can't build it for you because now we're in a range of beyond what base 10 blocks can show us. But I can visualize this, right? I can think, well, my divisor is going to be 4. My area inside will be 4,004. I can say, well, do I have enough for a 4 by 10? Well, that's 40. How about a 4 by 100? Well, that's 400. I still have a long way to go to 4,004. Do I have enough for 1,000 groups of 4? Of course I do, right? And a little sliver is left. So that makes 4,000 taken care of right away. And then what do I have left? 1 more 4. So my area is 4,004. My horizontal distance is 1,001, and I didn't have to deal with kids giving me an answer of an 11. And then they didn't understand why it was wrong. Like, that it's not reasonable at all. You're dividing 4,004 by 4, and they thought the answer was an 11 because they didn't bring down the zeros and put the zeros in the quotient, right? That doesn't happen when kids are thinking and reasoning with the numbers with the place values attached. That's what we need our kids to do to build their number sense. And when they go too soon to the algorithm, they're thinking in single digit facts. Very often, those single digit facts they have not learned to retrieve from memory. And so what are they doing to figure out that? They're skip counting. They're in an additive phase of reasoning, right? It's a collective connected journey we can do with our students. And let me show you how this also progresses now into the multi-digit work. Let's say for grade 4, where that was grade 4, right? 4 digit by 1 digit. Now going into grade 5 of the division, we're still continuing this journey, but now we have 2 digits that can come into the world, right? So we can use numbers in the range of the base 10 blocks to, again, help us visualize that it's the same thinking. I have an area model. The distance coming down my divisor is 12. I can think, well, do I have enough to make a 10 by 12 rectangle, right? And I do. I can move my 100 square right there. I can rotate 2 10 rods. So I can make a 12 by 10 area, right? So that area inside here is 120. And my distance up above here, again, you can put the rods out just to kind of see that it's that 10, right? So I know I've built a 10 by 12, which is 120. That's where I can be recording it as 120. But what I'm also going to do is I'm going to record up above here 10, right? I'm not doing that long division of just the 1. I'm going to record it as this 120, and I have up above here this 10. Do I have enough to make another 12, right? And in fact, I have enough to make 3 more sets of 12, right? And I can be moving these objects to build the 12. And there, all of my blocks have formed a rectangle. If it didn't, then it's not involving division or, well, say with division, we can have remainders. That's true. I take that back. So you can have remainders left with the division, right? In multiplication, it has to be a rectangle. So our job in division is to find the largest rectangle that we can using all the information that we have for that dividend, and then be able to, so this total amount here, right? We have our 36 more. That was the 3 groups of 12. So we have these 2 partial quotients, right? So we have this, the area model, but it still is making sense for the double digit divisors that we're doing. It's the same thinking that we're doing. We're following it through concretely and pictorially, and then we can get to abstract way, but we still can be recording these partial quotients like this, right? I can then do the subtraction. So I get my 36, and then we're scoring up above 6 more groups, which is the 36, leaving me with nothing and no remainder. And I have 16 groups, helping them attend to those place values as long as we can. Remember, standard algorithm is a 6th grade standard. Okay, now let's go into decimals. Let's go into the decimals and just show you, for example, how this works still with decimals thinking. So I used an equal group problem. Be aware that our standards require us to work on all these story problem types, the 9 story problem types, but also to use them with measurement examples. So it's not just other situations, it's also the measurement examples. So there's 1.8 meters of ribbon, 1 8/10. If a project needs 3/10 of a meter of ribbon, how many projects can be made? This is the quotative measurement division where I know the size. I'm going to take this length of ribbon and literally cut it at the 3/10 of a meter. So here you'll see Cuisenaire rods. We can use Cuisenaire rods for fractions and also for decimals, as well as the whole numbers. But I'm going to be seeing how many 3/10 fit into that 1 8/10. So a student can be thinking it through as having the 3/10. How many times that 3/10 fit in that 1 8/10? And of course, it turns out to be 6. Now, some more thinking that we can do. Here's the area model, right? So I can be building this to see how many 3/10 till I feel comfortable working with the decimals. That I can have the 3/10 over here, and I can think, well, are there any groups of 3/10 that I know for sure that help me get an area of the 1 8/10? Now, I am a huge follower of Pam Harris and Kim Montague, the 2 of them, their podcast. I listen to it every week. I have built my thinking and reasoning so much by listening to the 2 of them. And one of the major strategies that there exists in multiplication is that 5 is half of 10. And so 5 is half of 10 can help me here with my decimals. I know that if I had 10 groups of 3/10, that would be 3, because it's a shifting place value position. I didn't just add a 0 at the end of there, right? So if 10 groups of 3/10 is 3, then 5 groups must be half that, which is 1 5/10, right? So I can be recording that on an area model where I know I have my 1 5/10 as the area. And I'm almost to that 1 8/10. So I made my proportional area model as best that I can proportionally. And that is 5 groups. 5 groups of 3/10 is 1 5/10, right? It's 5 is half of 10. I use it all the time with decimals and things. It's crazy powerful, this journey. So what do I have left? I would do the 1.8 minus 1.5. I would have just 3/10 left, which is 1 more 3/10. And so that total distance is, again, the 6. So different pathways here. We're moving about that repeated addition that a student's going to enter in with decimals as the how many groups of 3/10 it is, but also shifting into that multiplicative reasoning, and the area model can make this visual so well as well. So that's an example there as we get into the decimal work. And then finally, we're going into division, our last little bit here. And I first want to show you an example here, which is something that I was not exposed to until many years into my teaching. And again, it's like, how do I get to be a certain age and not know this? Let me just copy it again. It just didn't grab one of the codes. Yeah, how did I get to be this age and not have known that? I find it a lot when I work in my districts talking about square numbers and talk about how that number can be shown as a square with like tiles. And they're like, wait, what? It's called a square because of that? Right? Yeah, it's a square number. All right, so here's the context of 2 granola bars being shared by different amounts of people. So we have our 2 granola bars, of course, these are the fraction tiles. I also love fraction tiles, although I also love using them when they're upside down because you can make the whole be different ones of them. You're limited to the one being the whole with Cuisinart, with the fraction tiles. In the Cuisinart rod app, you're allowed to change what rod you want to be the whole. Super powerful benefit with Brainingcamp. All right, so I'm going to bring down the two granola bars. And if it's shared by two people, of course, they're each going to get one, right? So we're going to have that be equal to a 1. Now, same two granola bars, but they're being shared by 3 people. And there are a variety of explorations kids can go through to do this. But let's just think about breaking apart one of the bars into 3 equal pieces. And then the other bar also into 3 equal pieces. And if it's a fair share, I can give a third to the person 1 and another third, a third of this bar and a third of this bar. So that each student would be getting 2/3 of a bar. Now, if I, again, copy down the 2 granola bars, now sharing it with 4 people, well, now I can be thinking about, well, what if I break apart each of the fraction bars into 4 pieces? And I can do the same thing with my other bar. And then again, I give them each 1/4 of each of the bars, right? And so they're getting 2/4 this time of a bar. And then same thing with the fifth. I just want you to see what you notice. What do you notice about what's happening with the context of the granola bars? These same 2 granola bars are being shared by different numbers of people. What do you notice? Right? Like it was 2 granola bars shared by 3 people. In this case, it was 2 granola bars shared with 2 people, which of course is equal to 1. The 2 granola bars shared by 3 people, 2 divided by 4 people, 2 divided by 5 people. Holy cow! If you ask me a story problem where I'm dividing something by a certain number of people, so let's say there were 3 granola bars shared among 7 people, each person gets 3/7. The 3 objects that are being shared and the number of people being shared. It is a crazy cool connection that I didn't know until many years in my teaching journey, but that fraction is division. It is 2 divided by 5. That's what 2/5 is. Crazy powerful. So one thing to be exploring in 5th grade is this relationship of fraction is division, right? So just a nice context there for you to use when you get the share codes from Mark. And then I also want to share a couple more things. This is an example here that I want us to touch base on. I mentioned earlier that our goal is not to get every single kid to the algorithm, and that is the end all and be all, so that they will do the algorithm whenever they see division, right? It's about knowing when to choose to do the algorithm and when I can choose to do other things, other flexible strategy that provides our students agency. So we want to build our students' identity, their belief in themselves to be able to learn math, and their agency. They show us with their actions that they know they control their learning, that they can solve things. And as Pam Harris and Kim Montague say, that they can figure it out, right? Math is figure outable. That's their site. And so here we have an example of a 16 divided by 8. So if I'm dividing by an 8, and I think about the quotative version of division where I know the size of the group, well, there are 2 8s in 16. 8 divided by 4, well, there are 2 4s in 8. 4 divided by 2, well, there are 2 2s in 4, right? So 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2, which means that I can have agency when you ask me to divide numbers to change the numbers I'm actually dividing with. Why would I choose to deal with larger numbers if I can divide them both in half and divide those 2 easier numbers to work with? Crazy powerful journey. Other flexible strategies. We can be scaling up or scaling down. It's a relationship between these two, right? If we think about division as being fraction, we multiply numerator and denominator by the same number to scale it up to get an equivalent fraction, right? It's the same relationship. Same thing if I divide numerator and denominator by the same number. We're doing that with fractions. We're doing it now with division, right? So just as a future impact of this, then, if I were to ask you to think about 144 divided by 18, like, woo, those are kind of wonkier numbers, right? But think about, I could divide it in half, right? That relationship will still be the same. So if I divide them both in half, half of 144 would be 72, and half of 18 would be 9. We're down to a basic fact, right? Double digit divisor. But in some numbers you give me, I can choose to make it more flexible, easier for my brain to work with. We also can scale up. So 6 divided by 1 and 5/10. What if I double both of them? Now it becomes 12 divided by 3. Holy cow. I want that for all students, to have that flexibility and that choice and build their agency. Holy cow, what a powerful journey. As we wrap up tonight, I'm going to touch a little bit about the 5th grade standard of a whole number divided by a fraction. And then we'll do the fraction divided by the whole number. So also we're in grade 5 again. We're working with our fractions. This is most state standards have this. So Kristen was going on a hike with her friends, and she has 2 cups of trail mix, and she had baggies that can fit a quarter of a cup, 1/4 of a cup of trail mix. How many friends does she have trail mix for? Again, quotative division. That's what we listen to when we think about the fractions, right? I'm not going to divide by a 4th and then fair share it, right? I'm going to be taking a 4th, and I'm going to be thinking, how many 4ths are there in those 2 cups? And so I can concretely be building it with manipulatives to see why it turns out to be 8. That seems crazy, right? When kids are used to working with fractions, the fact that my quotient's going to be a whole number can seem really crazy to them, right? But I also going to be thinking about my total amount. My area is 2. Do I know any amounts of 1/4? Maybe I know that 4/4 is equal to 1. So a 4 by 1/4 would make 1 whole thing. And I have enough for another 4 1/4 to make another whole. So my area is that 2. I'm dividing by a 4th, and my quotient is that 8, right? That's the total number of groups. So powerful work there. And then lastly, we'll do the dividing the unit fraction by a whole number. And this is where I do go to a fair share. This is the partitive division of the fair share. So a 4-person relay team needs to run a half-mile race. How far does each person need to run? So the team is just running a half-mile race. So how far is each person running? Each of the 4 people. Well, here I have again, an area model showing fractions. I've shaded in 1/2 already on the geo board here. So I'm dividing this half by 4. So what I like to do is I like to go to partition it horizontally. Do it the other way. So I've done the partition vertically of my 1/2, but I'm going to partition it in 4ths, 4 equal sized pieces horizontally. So you can see here, this 1/2 that I had turned into 4 pieces. But what is that in relationship to the whole, right? In relationship to the whole, it's 1 out of 8 pieces, right? So that 1/2 divided into 4 end up having an 1/8. So being able to visually see that as well. So, all right, my goodness, that was a really fast hour for me. I'm not sure about you, but that went by really quickly.